if we have 2 points in the plane, x1, y1 and x2, y2, and we want to compute the slope of the line that goes through these 2 points, then we just use this formula, y2 minus y1 over x2 minus x1. Let's suppose that we have these 2 points, let's say the point 1, 2, and 2, 3, 4, 5, 3, and 5, 3. Then what we need to do is we need to label the points. We can say that 1, 2 is our x1, y1, and 5, 3 is our x2, y2. Then in this case, the slope would be y2, let me just write it, y2 minus y1 over x2 minus x1, and y2 is 3 minus y1 is 2, 3 minus 2 over x2 is 5 minus x1, which is 1. Then this is 1 over 4. Then the slope is 1/4. Notice that it doesn't matter how we label the points. We can say that 1, 2 is the x2, y2, and 5, 3 is the x1, y1. And if we compute the slope, it will be y2, which is 2 minus y1 minus 3 over x2, which is 1 minus x1, which is 5, and this gives us -1 over -4, which is 1/4. Then when you want to compute the slope, it doesn't matter the way you label. The interpretation of a line is the rate of change of the function that line represents. Let me just tell you about the rate of change of any function. If you have a function f of x and you want to know the rate of change between, let's say, between x equal a and b, when x goes from a to b, then the rate of change is this quotient, f of b minus f of a over b minus a. This is the rate of change between a and b. And a linear function has the property that the rate of change is always constant. But remember that if we have a linear function, we have something like mx plus b, and then we have that y is mx plus b. But then when we know that, when we know f of a, if we know this number, it means that we know that this point a, f of a, is a point in the graph. And if we know the value f of b, it means that b, f of b, is a point in the graph. And if we label this as x2, y2, and this as x1, y1, then when we compute the rate of change, which is f of b minus f of a over b minus a, essentially we are computing the slope of the line. Then the slope of the line represents the rate of change of the function when that function is a linear function. And we know that a function is increasing when anytime we have that if we increase the x, the value of y increases. Then an increasing function is like this, and this, an increasing function has a slope bigger than 0. Let me write that down. If m is bigger than 0, then the function is increasing, the linear function is increasing. And if f is smaller than 0, then the linear function is decreasing. Then for a linear function, we can easily tell if the function is increasing or decreasing by computing the slope. When the slope is bigger than 0, the function is increasing, and if the slope is smaller than 0, the function is decreasing. Our observation is that if m is equal to 0, then the function is not increasing nor decreasing, it is constant. And in this case, the graph of the linear function when m is equal to 0 is a horizontal line.